do this. Okay, so this next section is 6.6. Now, properties of lifts. I'm going to show you all three properties, and then we'll go from there. First off, so we learned yesterday, let me show you, let me erase this first. Okay, that log base b of x equals y. Okay, now, I didn't actually explain how this happens, so we can use math to turn this into exponent form. How this happens is you take b to the power of that on both sides. You can do that because this base b, so whatever this base is, you can take the power on both sides. So b to the log, b to the y. These b's and the logs cancel out. You're just left with x, and b to the y turns into b to the y. That's how that happens, okay? Same thing can happen with, so that's a whole number and a subscript. Same thing can happen with this guy right here. So log subscript x of x equals a. Because you have a subscript with a whole number right next to each other, they're in the same multiplication product. They cancel out, you're left with only a, so a would be by itself. That's going to be really helpful here. Okay, so the first product is the product property. That means if you have one log or two logs separate, it usually starts with 2 and you're going that way, you can turn a log of a base of 2 numbers multiplied or one big number, you can turn it into 2 numbers multiplied into addition. So log base x of a times b equals log base x of a plus log base x of b. And obviously you can go from 2 of them to 1, so you can turn this addition into 1 log of multiplication. Now let's come down here. The quotient property. We can take 1 log of division or a number that we want to break down into 2 different numbers, okay? So log x of a over b, so multiplication turns into addition, division is going to turn into subtraction. So top to bottom, log base x of a minus log base x of b, okay? Last one, the power property. That means if you have a power in a log, you should rewrite it or can rewrite it and take this power and move it up front. So instead of being to the power of, it can be p times that thing. That helps when we have numbers, and I'll show you right up here. So here's some examples. Here's the very first one. You're given this. Log base 4 of 3 is this number. So this is a number that represents this, okay? And that is a true number. It wants you to find log base 4 of 192. So that's the problem we have. So you go, okay, log base 4 of 192. That's a big number. So you want to break 192 either into a number that has 3 in it and a number that has 4. Because remember over here, we talked about how the 4s cancel out. So those are our two numbers. You base it on the numbers you are given and its base. So divide it by 3. When you divide this number by 3, you get 3 times 64. Well, 64 is 4 to the third. So I can rewrite this as log base 4 of 4 thirds times 3. Now you look at it, okay, well, this multiplication can be turned into addition. So log base 4 of 4 to the third plus log base 4 of 3. Well, we learned up here that log base 4 of 3 represents a number. So you can substitute log base 4 of 3 with this decimal. And this guy, log base 4 of 4, since these are both 4s, this all cancels out and you're left with 3. Since they're all numbers, you can add them. 3 plus that decimal is obviously 3 point that decimal. That's easy. I'll go over here. I didn't finish it, but we can do it together, okay? So log base 4 of 2 equals 0.5. Find log base 4 of 32. So log base 4 of 32, use the number 2. Divide that by 2, you get 16. Well, 16 is 4 squared, so I rewrote it. So again, multiplication. So log base 4 of 4 squared plus log base 4 of 2. Well, the 4s cancel out, and I'm left with the whole number 2. Log base 4 of 2 is 0.5, so 0.5. Add those together, you get 2.5. That's your answer, okay? Now, let's see. That's another one. This has a power rule. So log base 2 of 5 is this decimal. It always goes 4 decimal places unless it's a short one like that 0.5. So with logs, if you ever get decimals, always leave it as 4, okay? So log base 2 of 25. So log base 2 of 25. Well, 25 is 5 squared. So there's no product here. right? They're not multiplying anything. We're really just 5 squared. So we can take this 2, move it in front. Well, log base 2 is something, represents that number. And look, you just multiply them by 2. That's your answer, okay? So you just have to think about it. The division ones are obviously the hardest ones, okay? Sometimes they're super easy. Like, look, this one, log base 4 of 5/3. I found out that log base 4 of 5 is this decimal. Log base 4 of 3 is that decimal, because we already used that one earlier. So this division means top minus the bottom. So log base 4 of 5 minus log base 4 of 3. So you go, the 5 one minus the 3 one, decimal. If it doesn't give you decimal, like it doesn't give you division, it doesn't mean it's not going to use division. Like 192, that's a big number. But if we had a number that wasn't that, right, and you could not find anything that uses the numbers they gave us, these numbers plus the base, to make it, that means maybe you should use division. Like the first one in the homework, I think it's a little difficult. You have to think about 18, okay? So then we're gonna use the same logic, but we're gonna solve with variables. So we have log base 6 of x plus log base 6 of x minus 9 equals 2. So you have the same log here. So we can take, since they have the same log and this is addition, we can turn these 2 logs into 1 log and then take this and multiply it by that. Okay, so then I have log 6 of x times x minus 9. I know that looks like a 6, but it's not. It's just because it's from the last part. So then that's there. Now we have a log base 6 we need to get rid of. Look, I can take 6 to the power of, 6 to the power on both sides of the equal sign. When I do that, these guys cancel out. That's 6 squared. So then you're left with x times x minus 9 and 6 squared. Well, 6 squared is 36, right? So I can take 30, and then this turns into x squared minus 9x. Well, when you have multiple x's, you want to move everything to one side. So I move that 36 over here. So now I have x squared minus 9x minus 36 and go, trinomial. You should factor it. When we factor it, what times what makes negative 36? Adds up to negative 9. It's negative 12 and positive 3. Remember, it still said equals 0, so we have to solve them. You get positive 12 and negative 33. You're not done. You have to check your answer. So over here's my checking. First, I plugged in 12. I just plugged it into the original problem. So log 6 of 12 plus log 6 of 12 minus 9 equals 2. So that simplifies to stay the same. This is log 3. I just ignored that for right now. So again, this can turn into multiplication. Log 6 of 36. Again, 36 can be written as 6 squared. What happens when you have 6's on top of each other? They cancel. You get 2 equals 2. So that one's true because it worked. Now, when I plug in negative 3, log 6 of negative 3, log 6 of negative 3 minus 3, okay? This one does not work right here, right away, because you cannot take a log of a negative number. So if you just have an x in your problem right here, and you have to plug in a negative number, it automatically is undefined, so that number can never work. So our only answer, when you write your answer, you would just say x equals 12. That's the only answer that actually works. Then on the back, there are 2 problems. Okay, big enough for you to see them. You can pause them here and look at them. The answers, right? So the work, and then the checking, so then the final answer. The work, the 2 answers, and then the checking, the final answer, okay? Check and see if you get the same thing, and then try them from your homework.